The next one can sure be called an advocate for innovation, for sustainability, for circular economy projects. He's now part of two NGOs, IoT Austria and Mariahilfer. And together with smanda.com, they developed a challenge and brought it to us about self-containment of household gear, I would say. Would this be correct? Patrick Awart, welcome on stage.
Hello everybody, thank you for the charming introduction. I hope I will get along nice with the microphone, better than the last time. Before I start, I would say thank you for Sandra for bringing together the people that I've encountered in the last few days during the hackathon. It's about hearts and minds, and I consider this currently some kind of a bubble, but it would be really cool in taking out all of this positive spirit, and I was lectured by Sandra also energy to into the outside of this bubble. If you see like what is happening currently in the world, so we really have like cool sustainable solutions here, and that's where I come back to our topic. It's take back control. Who hasn't encountered the situation that you have a washing machine, for example, at home or any other home appliance, and mechanically it would still be okay, but electronically it has failed. So then you're there, hardly anybody is going to repair it, and you have to throw it away. So this is electronic waste at a scale at the moment that is just preposterous. And we have to tackle that problem. It's getting better with product passes on a European level, with indications of repairability and so on and so forth. So it's moving slightly in the good direction. Then again, we have the Green Deal that is kind of cut in the middle. So it comes back to us. Whether we want to take control or not. And the project that we have started here 1 year ago was basically ripping out the electronics from a washing machine and developing a generic electronic. It has to do with sovereignty, not sovereignty on slides, but really down to earth. It has to do with developing the electronics, the software and so on, and understanding design principles, security layers, like how is a washing machine actually designed. And it's also interesting to find those patterns then in other devices. So what we're doing here is actually, now we're starting with a washing machine, but what we're really doing is introducing a new platform and a new way of thinking about how we want to interact with our appliances. It's not longer a washing machine or a dishwasher or something else. As we've seen with the houses before, wonderful comparison. It's an integral part. So we want to have appliances that we own, that we can modify, that we can potentially hack the way we want it. And all the rest is crap. So what we did, we have the hardware, and in these 3 days, Franz, I want to congratulate you to your great students. They have taken upon them 2 challenges. The first challenge was to develop, we just had a basic small tiny program on this, to develop a real program that would do a minimum washing program. They're going to demo it afterwards. I'm not going to say anything more about that, so great work there. The second part is to integrate this with an I2C bus, open standard again, into a smart controller that would then not only steer the program, but also be able to be nicely, locally integrated into your home appliances without any cloud, with any fuzzy applications that change from day to day, where your data is flying around and so on. So a full sovereign solution that is taking back control for yourself. Okay, great, we'll show it afterwards. We are moving also towards load profile optimizations and other things. Interestingly enough, with this very techie point, and this very, let's say, platform idea, we did not frighten off somebody who came along, the vice dean, and said, okay, sorry, yeah, thanks. And she said she wants to develop a business plan with us, so this is what is going to happen tomorrow. This is why it's a gray hook and not a green hook. And yeah, so this looks like a lot of motion in a quite positive area, and I would say thank you. Please, the floor is yours.
And the team up on stage, Max Riegler, Daniel Fock and Kevin Lang.
So, hello. We were presented with this challenge of a washing machine which was electrically damaged, not mechanically, but the main board was damaged, or is often the case with washing machines. And we were given a circuit with a microcontroller which has no programmers and yes, it didn't do anything. It was just physically here. And yes, there were a few in and outputs from the washing machine, like the fill level of water or the motor which is spinning the thing inside. And yes. So this was the starting point. There was the main PCB, which you saw earlier, with a controller, with a microcontroller without a running program. We wanted to make this virtual, as we didn't want to take a washing machine here or without at home. So we did a virtual simulation of this thing with our own microcontroller, which represented this board, and made some in and outputs ourselves. The LEDs you can see are representing like the door lock or the engine or yes, these things, all the actuators of the washing machine. And there are also some inputs like a stop button and the speed of the motor. Yeah. So this was basically our concept, the real circuit. We changed the microcontroller to another more usable type for us, which we had at home. And yeah, there was also another controller, an ESP32, which had Wi-Fi capabilities and is very good for home applications. And so we wired these things together. The microcontroller for the washing machine, for the controlling of the washing machine, was wired with I2C to the ESP32, and so these two are communicating together. The ESP is catching, it is monitoring the fill levels of the water level, and is telling, the ESP is telling the microcontroller to do some things, what you tell them to do. So we created a web interface where you can start the washing machine with the programs needed, and where you also get the measurements like the temperature of the heater or the rotational speed of the motor. So, and we built this in real life on a breadboard with some electrical components, and did a quick test run to see what it will do with a real washing machine. Yes, on the right-hand side, you can see the interface where you can put in some variables or the programs you want to start the washing machine. On the left side, you're seeing the outcome of the program. Just need to click. Okay. We simulated things like rotational speed or temperature. We simulated them with potentiometers, so you don't have any temperature sensors or something like that. And yes, with this simple build-up, we could check if our program works and if the connection between our home assistant and the microcontroller is working. We published this also on GitHub and made a small technical documentation, so other teams can build up from that or work from here, from this state. Yeah. Yes, thank you for your attention.
Thanks very much. That was a team of the University of Applied Science, St. Pölten, by the way. And Patrick is also collaborating on this together with another a historic collaborator of Industry Wiz Makers, Clemens Meyer of Makes and Smanda.com. He cannot be here with us now because he is on the E-Day, which is running in parallel. Thank you very much, guys. Take your picture and do take your Emmys.